Hello friends, welcome to Learner's Planet. Friends, this is the third session for the number system workshop. In the previous session, previous two sessions in fact, we have done good number of problems based on remainders. And in the last session, I asked a set of questions and that I am going to solve in this session. Okay, so I am sure you might have tried to solve all these questions. Just match your answer and solution with mine. Okay, so let's begin. Now the question was x is equal to 2043 raised to 2043 raised to 2043. If this number is divided by 2, 3, 4, 5, 6, 7, what will be the remainder, right? So let's do one by one. See, as far as 2 is concerned, it's very simple because it's an odd number. So if any odd number is divided by 2, the remainder is 1, right? So 2, 3, 4, 5, 6, 7, 8. Okay. So remainder from 2 is 1. Then from 3, let's see, 4 and 3, 7 and 2, 9. So this number is multiple of 9. So while divided by 3, the remainder will be 0, right? So from 3, the remainder is 0 as well as from 9 also the remainder is 0, right? And if you divide any number by 9 and if you get the remainder as 0, that means digital root will also be 9, right? See, listen to me carefully once again. If you see, in the last session I asked you to find out the digital root, that is if you expand this number and sum up all the digits till you get a single digit, what that digit will be. So precisely I was asking what is the digital root of x. Okay, so since this number 2043 raised to this is divisible by 9, right? That means the digital root will be 9 only. Okay, getting my point? So digital root is 9, right? Divisible by 9, remainder is 0, that's why digital root is 9. Okay, now from 4, so this 2043, so that's actually 2044 minus 1 raised to this story. So the remainder is minus 1 raised to this number, right? Now this 2043 raised to 2043 is obviously an odd number. So minus 1 raised to odd number, so the remainder will be minus 1 only. So the final remainder is 4 minus 1, 3. Okay. Now let's take the case of 6. See, this is multiple of 3 as we have already discussed, 3 and 9 both as well. So in any multiple of 3, that is odd multiple of 3, while divided by 6, the remainder is always 3. Okay, you can take any example, maybe 15, maybe 21, maybe 27. Any of the odd multiple, when they are divided by 6, the remainder is always 3. Okay. Now we have to see from 5. See, in the case of 5, if at all we find out the unit digit of this expression, then also we can get the remainder. Okay, now how do we find out the unit digit? For that, you might have attended my unit digit session, that is cyclicity of power, right? So after every 4, the cycle repeats in case of 2, 3, 7 and 8, right? Here the unit digit is 3, so the cycle is of 4. So first of all, I find out 2043 raised to 2043 is which cycle? It's 4k format, 4k plus 1, 4k plus 2, 4k plus 3, right? So for that, 2043 raised to 2043, I need to find out the remainder while it is divided by 4, right? So that's minus 1 raised to 2043. So that's minus 1 because minus 1 is having odd power. So finally 4 minus 1, the remainder is 3. That means this number is actually 4k plus 3 format. Okay, 4k plus 3 format. So I can write 2043 raised to 4k plus 3 format. Okay, now 4k plus 3 format, that means third position. 3 3s are 9, 3s are 27, right? The third position. Now that means unit digit of this number will be 7, right? If unit digit is 7 and if you divide it by 5, then what will be the remainder? Obviously 2. Okay. Now let's see from 7. See, 2043. What is the divisibility rule of 7? From this last 3 digits, you need to deduct the first 3 digits, right? So here just we have to deduct 2. So 43 minus 2, 41. That means this number is not multiple of 7, right? Because 43 minus 2, that's 41. That is not multiple of 7, right? Instead of 43, if it would have been 44, right? Then 44 minus 2, 42. That is multiple of 7. That means 2044 is actually multiple of 7. So this number can be written as like this. And this is the power, right? So the remainder while divided by 7 will be minus 1 raised to this entire figure, and this is an odd figure, so the remainder will be minus 1 only. So if I divide this number by 7, the remainder is minus 1. That means the positive remainder will be 7 minus 1, 6. Okay, isn't it very easy? Now friends, let's find out the remainder while divided by 8. Now 2040 will be the last multiple of 8. So the remainder is 3 raised to 204343. 3 raised to 2043 raised to 2043, right? Now in the power of 3 we have a number 9, that is just 1 having difference as 1 from 8, right? So what we do, we convert this number to power 2, and let's see what happens. So this 2 raised to 2043 raised to 2043 is what? 2k plus 1, isn't it? If we divide this number by 2, what will be the remainder? 1, right? So this is actually 3 raised to 2k plus 1. So that's 3 raised to 2k into 3. So that's 9 raised to k into 3, right? Now 9 is what? 8 plus 1. So if you divide it by 8, remainder will be what? 1 raised to k. Now it doesn't matter k is an even or odd because we have the positive 1, right? So the remainder is 1 into 3. So the final remainder is 3 only. Okay, I hope you are getting me. So in each case we have found out the remainder. If you wish to find out the remainder while divided by 10, that will be as good as the unit digit of this expression that we have already calculated in the case of 5. So in the case of 10, if you wish to find out the remainder will be 7, since the unit digit was 7. Okay, so while divided by 5, the remainder was 2. Okay, so till 10 we have already done. Now friends, let's see how do we find out the remainders in particular cases. Suppose I talk about say if this expression is divided by 15. Now 15 is factorized as 3 and 5, right? While divided by 3, the remainder is 0, that we know. While divided by 5, the remainder is 2, that we know, right? So suppose x is divided by 15, then remainder is what, right? Just listen to me very carefully. This number is actually 3x format and 5x plus 2 format, right? So what you do, you see this is x, then this must be some other variable. Okay, since x and y are quotients, so they need to be different, right? Now what you do, you keep on putting the value of y in this expression and see where you find a number that is multiple of 3. Suppose I have 1, right? So 5 plus 2, 7, that's not multiple of 3. If I put y as 2, then 5 into 2, 10 plus 2, 12, right? So 12 is multiple of 3 and that is into 5 plus 2 format, right? So 12 will be the remainder when this expression is divided by 15, right? That's very simple. Just try to understand it once again. The number 15 is multiple of 5 and 3 4. I have done factorization of 15. That's 3 and 5. So while divided by 3, the remainder is 0. While divided by 5, the remainder is 2. That means the number is 3x and 5y plus 2 format, right? I started putting the value of y as 1, 2, 3, 4. So and just we have to see that which number is a multiple of 3. Okay, now if I put y as 1, I'll get 7, so that's not multiple of 3. If I put y as 2, I'll get 12, that is multiple of 3, and it is 5y plus 2 format. That means if I divide it by 15, the remainder will be 12, right? It is that simple. Similarly, if I have to see if this is divided by 12, then what will be the remainder? Now 12 is what? 3 into 4. Okay, so the number is 3x format, or we can say 4y plus 3 format. right? Now once again keep on putting the value of y as 1, 2, 3. If I put 1, then 4 plus 3, 7, not multiple. If I put 2, 4 2s are 8 plus 3, once again not a multiple of 3. Now 4, if I put 3, so 4 into 3, 12 plus 3, 15, right? So 15 is 4y plus 3 format, and as well as it is multiple of 3 also, right? So if this expression is divided by 12, the remainder will be 50. Okay. Similarly, suppose you have to find out from 21. Now 21 is what? 3 into 7. So 3x and 7y plus 6 format, right? If you put 1, the remainder, the solution will not be multiple of 3. If you put 2, still not. 7 2s are 14 plus 6. If you put y is equal to 3. If you put y is equal to 3, then what will happen? 7 into 3, 21 plus 6, 27. Now 27 is the number that is multiple of 3, and that is in 7y plus 6 format, right? But since 27 is bigger than 21, so what we can do? We can deduct 6 from it. I'm sorry, 21 from it, right? So 27 minus 21, the remainder is 6. So if this expression is divided by 21, the remainder is 6, right? If you put y as 0, you'll be getting the instant answer, right? Because if y is 0, this number is 3x format as well as 7y plus 6 format. Okay, so either you put y is equal to 3, so you'll be getting 27. Now 21 and 27, the difference is 6, so that's why the remainder is 6. Okay, I hope you are clear. Similarly, friends, you can make other combinations as well, right? So 3x, and suppose we have to find out the remainder by 30. Okay, so 3 and 10 can be taken, right? So this is 3x, and that is 10y plus 7, right? If I put y, 17 is there. If I put y is 2, so 10 2s are 20 plus 7, 27, right? So 27 is multiple of 3, and it is in 10y plus 7 format. So that will be the remainder if this expression is divided by 30. Okay. Now all of these were very simple because we are making the combination from 3 and some other number, right? Now what happens when the combination of other numbers are taken? In this case, since the number is already divisible by 3, it's very easy to find out the combinations from 3, right? But if we suppose we take the remainder from say 20, right? So 4 and 5, none of them is multiple of or factor of this. Okay, in that case what happens? Let's see. Now from 20 we find out the number is 4x plus 3 format, or we can say 5y plus 2 format, right? Now in that case what you have to do, whatever the value you are putting for x and y, you have to match a number that comes in this sequence and this sequence, right? Suppose I take x as 1, so 4 plus 3, it is 7. Y, if I take y as 1, still I get 7. That means 7 is a number that is in 4x plus 3 format also, and 5y plus 2 format also, right? So if you divide this expression by 20, definitely 7 will be the remainder. Okay. Similarly, suppose we have to find out the remainder from 28. So that's 4 into 7, right? So 4, the number is in 4x plus 3 and 7y plus 6 format, right? Now this may take a bit longer time, because if you put x as 1, it will be 7, it will be 13. Not same if you put 2, so 4 2s are 8 plus 3, 11, and if you put 2 over here, 7 2s are 14 plus 6, 20. If you put x as 3, then 4 3s are 12 and 3 15. If you put y as 3, 7 3s are 21 plus 6 27. If you put x as 4, so that's 4 4s are 16 and 3 19. Now here we cannot put the more value because it cannot be more than 28. And lastly, if I put x as 5, so 5 4s are 20 plus 3 23. And if you put x is equal to 6, that is 4 6 are 24 plus 3 27, right? So 27 is the number that is in 4x plus 3 and 7y plus 6 both formats, right? So if you divide this expression by 28, the remainder will be 27. Okay, I hope you are getting me. So this way you can make various combination and practice with that. Lastly, we see from 42, so that's 6 into 7. So the number is in 6x plus 3 and 7y plus 3, 7y plus 6 format, right? So 7y plus 6, if I put y as 1, it's 13, y is 2, 7 2s are 14 plus 6, 20, y is 3, then 7 3s are 21 plus 6, 27. So 27 is the number that is in 6x plus 3 format also. So 27 will be the remainder if this expression is divided by 42. Okay, so now I'm sure you are clear with each and every aspect. How do we get the remainder when they are divided by these many numbers? How do we get the remainder when we are making various combinations? Okay, so bit practice is required. After that, you will be getting a great grip over number system problems specifically based on remainders. Okay, so let's move on. Now let's try some more questions based on remainders, so you get a great grip over the topic and you should not mess up even a single question that is asked in CAT, right? 90 raised to 90 divided by 13, what is the remainder? No need to go for any paperwork. 90 is the what? 91 minus 1. 91 is multiple of 13, so the remainder is minus 1 raised to 19, that means 1, right? Next is I'm having a problem that is 3 raised to 202 divided by 101, what is the remainder? In this case, we are going to use Fermat's theorem. That's an important theorem. Now what happens exactly in this theorem? Suppose I have any number, that's P, right? That is divisor, and any other number that is co-prime to P, right? Suppose this number is N. Then N raised to P minus 1, if it is divided by P, the remainder will be 1, right? Remainder will be 1. Okay, again listen to me carefully. N is any number, not necessarily to be prime. N is any number, but P is prime number. So N and P, they should be co-prime to each other. Okay, so N raised to P minus 1, if it is divided by P, the remainder will be 1. Suppose I take say N is 6, right? So 6 raised to 6, if it is divided by 7, the remainder will be 1. Similarly, if I take 8 raised to 7, 8 raised to 6 divided by 6, then also the remainder divided by 7, then also the remainder is. Similarly, 4 raised to 6 divided by 7, the remainder is 1. 5 raised to 6 divided by 7, the remainder is 1, right? So this is the factor theorem that is going to be important one. So the same we will be using over here. Now in that case, this is 202. So that's actually 3 raised to 100 into 3 raised to 100 into 3 raised to 2, right? Now 3 raised to 100, this is actually 101 minus 1, right? So 3 raised to 100 divided by 100, the 101, the remainder will be 1. Here also the remainder is 1 and this is 9. So 1 into 9, the final remainder will be 9 in this case. So if you know the Fermat's theorem, it will be very easy for you, just a matter of 20 seconds. Okay, I hope you are getting it. Just note it down. Now I have 10 raised to 200 by 8. In this case, I have to find out the remainder. So do I need to calculate it? But obvious the answer will be 0 because 10 raised to 200 is multiple of 8. Even 10 raised to 3 is multiple of 8, isn't it? 1000 divided by 8, you'll be getting 125. So this is much bigger, right? So that is definitely multiple of 8. So the remainder is 0, right? Now I have the other expression, 10 raised to 10 plus 10 raised to 100 plus 10 raised to 1000, and this expression, if it is divided by 7, what will be the remainder? Okay, by 7. So in this case, it is 3 raised to 10, 3 raised to 100, 3 raised to 1000. The first step. then this can be written as 9 raised to 5, 9 raised to 50, 9 raised to 500, right? Now this is further, if I divide by 7, the remainder will be 2 raised to 5, 2 raised to 50, 2 raised to 250. Okay, now 2 cube is actually 8, that is closer to 7. So this is 2 cube into 2 square. It is, and 2 cube when divided by 7, the remainder will be 1 only. Okay, because this is 8 is 7 plus 1. Okay, here 2 raised to 48 into 2 square. 2 raised to 48 is what? It's actually 8 raised to 48 divided by 3, 16. So that's 7 plus 1 raised to 16. So 1 is the remainder. So that's 2 square we are left. And here also this is 500. This was actually 500. So 500 is 2 raised to 498 into 2 square. 2 raised to 498 further will be able to convert that into 8. So finally 2 square plus 2 square plus 2 square, that is 4 plus 4 plus 4, that's 12. Again 12 is divided by 7, the remainder is 5. Okay, so the final answer is 5, right? If the sequence goes on till 10 raised to this 10 digits, still the same answer will, similarly you can find it out. In that case 4 into 10 times 40, and 40 divided by 7, the remainder will be 5 only. Okay, so this way you can proceed. I'm sure you are getting me. Now I have 7 raised to 11 raised to 22 raised to 33 raised to 44, and if this number is divided by 5, what will be the remainder? See, in the case of 5, if at all we find out the unit digit, that's enough for us to find out the remainder. Now how do we find out the unit digit? For that we need to work on the cyclicity of 7, and cyclicity of 7, that is a cycle of 4 only. So we have to find out whether this number is in which format: 4k, 4k plus 1, 4k plus 2, or 4k plus 3. Okay, so 11 raised to 22 raised to 33 raised to 44. Now we have to see this portion only, in which format this is. Now 11 is actually 12 minus 1. Now this is 22, 33, 44, right? So while divided by 4, the remainder will be minus 1 raised to all this. Okay, now 22 is an even number, right? Now even number must maybe having any power, the number will still be even. So while divided by 4, the remainder will be minus 1 raised to even number, that means it is 1, right? So this number is actually, the entire number is 4k plus 1 format. Getting my point? So if it is 4k plus 1 format, it is 7 raised to the unit digit of this will be 7 raised to 4k plus 1, that is first place, 7 itself, right? And if 7 itself is unit digit is 7, and if it is divided by 5, the remainder will be 2. Okay, now seems to be complicated, but that's very easy if you are conceptually clear. Okay, in case of 5, it is but obvious that you need to find out the unit digit. For unit digit, you must be knowing the cyclicity of the power. In case of 2, 3, 7 and 8, the power cycle is of 4. So you divide it, this expression, convert this expression into 4k, 4k plus 1, 4k plus 2 or 4k plus 3 format, right? Whatever the format you are getting, according to that you can choose the unit digit, right? This is actually 7 is to 4k plus 1. So 7 is to 1, 2, 3, 4. So that's the first position. So unit digit is 7 only. Unit digit is 7 divided by 5, remainder is 2. That's it. Okay. Next is, suppose I have a number 1 factorial plus 2 factorial plus 3 factorial till 105 factorial. If this expression is divided by say 40, then what will be the remainder? Okay, let's see. Now 1 factorial is 1, 2 factorial is 2. This is 6. 4 factorial is 24. 5 factorial is 120. So after 5 factorial, each and every number will be multiple of 40. So we will not be getting any remainder after this. Okay. So till here the remainder is 24 plus 6, 30, 32 and 133. Right. So it's very simple. If this expression is divided by 40, the remainder will be 33. If this expression is divided by say 24, then the remainder will be obtained from this 3 figure, because this number itself is multiple of 24. So 6, 7, 8 and 9. That will be the answer. If this expression is divided by 3, then the remainder. So still this is the multiple of 3. So just 2 plus 1, 3 divided by 3, the remainder will be 0 in that case. Okay. Now suppose you have to find it by 9, then what will happen? In the series of factorial, the first number that will be multiple of 9, that is 6 factorial. Okay, so before 6 factorial we have to consider each and every number, right? Now we can eliminate 24, 25, 26 and 127. Eliminated the multiple of 9, then 120 plus 6, 126, that itself is multiple of 9. So precisely this entire expression is multiple of 9, so the remainder will be 0. So this way you can find it out. Okay, if you have to divide it by 8, then find out the remainder. Still 6, 7, 8, 9. The remainder will be 1 only. Okay, because from here all the terms will be multiple of 8. Okay, so this way you can practice. Looks like difficult because the series looks very big and factorials are also there. So sometimes students they find it very difficult to crack. But once you have done this sort of problems, it's very easy to do. Okay. Now sometimes even this sort of expressions are made complicated. Say 1 factorial raised to 1 plus 2 factorial raised to 2 plus 3 factorial raised to 3 till 100 factorial raised to 100, right? Maybe the 100, maybe 1000, whatever, doesn't matter, right? Now what we can do over here, if this expression is divided by say 24, what will be the remainder? Okay, now 3 factorial itself is 6 and 6 cube we are having over here. So 6 cube is 216, that is multiple of 24. So the terms after this expression will definitely be multiple of 24. So we have to calculate this 2 factorial raised to 2. So this is 1, 2 factorial is 2, so 2 raised to 2, it's 4. So finally the remainder will be 5, right? So pretty simple. If you put factorials over here, still doesn't matter. The remainder will be obtained from this position only. Okay, because now it has become more simpler because this number is bigger than 216. So even if 216 is multiple of 24, the number multiple of 216 will definitely be multiple of 24. So no remainder will be obtained from these. So you can find out the remainder from this position. Now 2 factorial is 2 only. So that's 1 plus 4, 5. Okay, so in both the cases the remainders will be 5. Right? So problems are pretty simple. Looks like difficult, but believe me, very simple. Next is we have a problem that's 7 plus 77 plus 777 plus 4 times 7 till 100 terms, right? This is an expression that is x. If x is divided by 8, then what will be the remainder? Okay, now pretty simple. Here the remainder is 7. Here the remainder is 5. Here if you divide it by 8, 8 9s are 72. 5, 7, the remainder is 1, right? Again in this case 9, 1. Again you take 17, the remainder is still 1. That means from this number onwards you'll be getting the remainder as 1 because every time you'll be left with 1 and the next number is 17. So 1, 7, 1, 7, the remainder will be 1 always. Okay, so 1, 2 terms are there. So 1 98 times, so that's 98, right? So in all, we have to find out the remainder of this total while divided by 8. So 98 divided by 8, the remainder is 2. Then 7 plus 5, 12 and 2, 14. So finally 14 divided by 8, the remainder is 6. Okay, just do not get confused by looking at this big term. It's pretty simple. Okay. Friends, I hope you might have enjoyed this session and you'll be learning some new concepts as well. So do practice with them. In the next session, I'll be coming with some more concepts, some more problems. Okay.